Hi, I'm Steve Doubleday, and I've been working in computing for upwards of 35 years now, split pretty evenly between operations and development. About 20 years or so ago, I learned about something that came to be called agile development, and I was an early convert and an early champion. We had some good initial successes, and we had some problems, and that unevenness seemed to persist over time, so much so that in 2012 I stopped working for a number of years and started a doctoral program. And my question going in was, why is it that big organizations have such consistent problems writing big computer systems? This is one of two talks where I try to bring current findings from cognitive and neuroscience to bear on the question of how might we do better at software development. We'll talk about three frames and accompanying metaphors. Not that there aren't lots more than three frames in the world, but three is an easy number for our brains to remember, and we're all about today understanding more about how our brains work and what that means for software development. I'll suggest that we think about writing software in terms of running a project to construct a big building. Start with a metaphor that a system is a building. We begin with a foundation, we've got some sort of structure or framework, we've got a process of filling that in to create our building. The second metaphor is that building a system is running a project, which brings the project frame to bear on our software world with things like a problem, requirements, an architecture, and various phases of work. Finally, we think of writing software as production, and that brings in a frame called more, where if we need something more, we just give more inputs. More inputs gives you more outputs. And we contrast this way of thinking. We ask ourselves, how do we get from this way of writing software and thinking about software to this nifty new way, the agile way of starting with stories, supporting those with automated tests and coding in small steps with refactoring, versioning our software infrastructure, and deploying very frequently into production, such that our life is a series of very small steps. So getting from the old way, the place where we currently stand, to this new way seems to us as involving a big lift. It's hard to get from where we are to where we want to be. An awful lot of our thinking is about what life will be like once we climb over this obstacle. But the talk today is to focus on where we stand, where we start from, and to think about how these three frames, the building, project, and more frames, shape all of our attempts to become more agile. Let's start with the concept of metaphor. In sixth grade English, we heard love is a rose, and we talked about how a rose is fragrant and beautiful, but it sometimes has thorns, and these are things that might help us think a little more colorfully, with more vividly about that abstract thing called love. And so what we came away with in sixth grade English is the notion that metaphors are interesting, but maybe they're not real, that they're kind of a flourish around the edges to make our life and our reading more compelling. But the current science suggests the opposite, that instead of being metaphorical and not quite about the real thing, that metaphors are one of the fundamental mechanisms by which our brain understands the world. Let's do an example. This woman is pushing a truck. She's giving it her all, and if we were able to look inside her brain, we would probably be unsurprised to see that the areas at the top of the head that are the motor cortex, which organize physical activity, that they're all lit up, that they're incredibly busy right now. But it might surprise us a little more if we could look inside the brains of the two guys who are watching her, because it'll turn out that the motor cortex is the most active part in their brains too. And that's because primates understand what's going on in other members of their group, in large part by simulating the actions that they see. So what's happening here is these fellows are mentally pushing right alongside her, trying to move that truck. So that's kind of interesting. Perhaps even more surprising is that when we get to something truly metaphorical and abstract, like this sentence, Europe is pushing obstacles out of its path to economic recovery, that the way we understand that sentence is we start by mentally simulating the actions that are implied by it. So in order to understand this metaphor, we start by mentally pushing that obstacle out of the way, just like that truck. So it turns out that metaphor is far from being superfluous or extra in some sense, is a fundamental mechanism that we use to understand the world even at its most abstract. So what's a frame? Let's start at the very beginning. Here I've got a pen. So if I were to let go of this pen, none of us have any trouble at all predicting exactly what would happen to it. And we might ask ourselves, well, when did we learn that? Well, did we learn it in 8th grade science when they taught us about Newton and apples and gravity? No, we actually learned it much, much earlier than that, long before we could talk, maybe around 3 or 6 months. Basically, what we're doing in that first year is understanding how things move in the world, how our body works, where our limbs are, how we reach and grab things or push things, how we move from here to there. Somewhere around 6 months, my granddaughter decided that one of the most fun things in the world was to pull herself up on the edge of the crib and hold a toy and then let go of it and watch Granddad smile and bend over and pick up the toy and hand it back to her. And she decided that doing that over and over and over again was just tons of fun. And then after some period of time, she got bored with that and went on to something else because she understood now what happens when you let go of something. And so this happens over and over again in the physical world for baby, and baby also learns a lot about the social world, understands that if she cries, someone will feed her or change her. If she holds out her arms, someone will pick her up and hug her, and she'll feel warm and loved. And all of these things happen long before she can talk and form the basis for understanding metaphors like pushing obstacles. Then, as she begins to get words for things, she can speak about them, but the physical things she learned early on always stay with her. So a frame is about how we think about a particular kind of situation. Let's take that many years forward and think about our 3 frames for software development. When we say a frame is about a situation, we start with a set of elements, some roles, for example, client, architect, worker, and some artifacts like requirements or a blueprint. In the building frame, we take those elements and we combine them in some set of scenarios. In this case, workers build the building following the blueprint, or the clients break ground after the design is complete. And we got 4 middle-aged guys pretending to do some work. And if we take that frame, which starts in the world of physical construction, and we use the metaphor that a software system is a building, then we've got a source domain, and we're now mapping it into a target domain of software. And the building frame works okay there. We've got the notion of an architecture, got the notion of an architect, client. It seems to work okay, but we're aware that software is not steel and concrete. And the rigidity of a building isn't something we want to aspire to in our software. And yet, we still think of things as we need a solid foundation and we've got to have a rigid framework. That sort of thinking acts as a drag on us because it assumes that once we put it in place, we can't change it. We've got a 4-story building, and the 3rd floor we decide isn't meeting our needs. And if we take the third floor out of a physical building, the whole thing will collapse. On the other hand, we know that in software, if we've got 4 layers, we could replace a layer if we were careful. And that's the flexibility that software brings that building does not. And so if we think hard about it, we can accept the difference between the building frame and the software frame. But unconsciously, those two are always talking to one another. So there's a challenge in the building frame that suggests that we ought not to take it as seriously as sometimes we do. It has a neighboring frame. This is not one of our main 3, but this one's so close to it that it's worth taking a minute to talk about it. And it's called the asset frame. And the asset frame is about taking a pile of money and building an asset. Its elements are, we've got capital funds, operating funds, we have some asset that we're going to build, and an owner. And the scenario is the owner invests a large amount of capital funds to build the asset. And then the follow-on scenario is that the owner maintains the asset over a long period of time by spending small amounts of operating funds. So this asset frame and its very closely related neighbor, the building frame, work together to shape a lot of how we think about software. We think about building a big building of software, spending a lot of money to build this asset, and then we maintain it, trying to keep its lights on. Take that straight out of the building frame. Keep the lights on, just spend enough money to pay for our electricity, and we'll maintain it that way over time. And the challenge there is that what experience tells us is that a more moderate amount of spending indefinitely over time allows us to build something that works more like a product, where it's never perfect, and over time it's going to modify to meet the needs of the market, and we move away from the building and asset frames. Let's talk about the project frame. So the fundamentals of the project frame are that we've got 4 elements: a list of tasks, a schedule, a budget, and a set of resources. And our core scenario is that the project manager, the key role, trades off among these elements to accomplish the objective. If we're short on time, we spend more money because time is money. Or we shrink our list of tasks, our scope. So that's the core of the project frame. We use a metaphor that building a system is running a project. To go from the domain of project management over to the target domain of writing software. And we use this metaphor to say we can we can build our software system using the project frame to manage the trade-offs that come with dealing with software. But the problem is that when we're writing software, we're not just typing. It's not that, although a big system has more lines of code than a small system, it's not that the work is just writing more lines of code, where each line is like a brick. When we're writing software, we're not laying bricks. Each brick is like every other brick, but each line of software is very intentionally not like any other line of software in the system. That's the point, is together they create something that's different from just piling one line of code on another. Instead, we're creating problem representations. And this is my second talk. I'm not going to do that talk here. I'm going to not go into the details. But the bottom line of that talk is that when we are creating problem representations, we're doing something that has an unpredictable duration. There's not a way to predict how long it's going to take to do that. Let's say we have a problem domain, a real set of activities in the world that we're trying to represent in software. We're building a solution domain in software, and our intent is that in software we can manage something about this problem domain and make our lives easier, more economical in that problem domain. And the way we map from this problem domain over to the solution domain is by building many different problem representations. And that goes from a few lines of code on up to the whole system. And it's recursive at many different levels, and each problem representation has some unpredictability about it. And it's that unpredictability that poses the biggest challenge for the project frame. The biggest place where it's not a perfect match for the business of writing software. And in some sense, the whole notion of Agile is a way to manage that unpredictability. To say, we don't really know how long it's going to take, but we'll just work on the most important thing, and we'll keep repeating that, and as we finish it, we could decide to stop and declare victory. That's a way to, in essence, manage the unpredictability of writing software in a way different from the way the project frame invites us to think about it. Okay, let's move on to the more frame, which is the one that's most deeply embedded in our brains and, I suggest, causes us the most problems in combination with the other frames, but this is the one that leads us farthest astray. The elements are simple. We've got inputs, we got outputs. And our scenario is that more inputs gives us more outputs. Where did this start? Well, it probably started watching Mother pour water from a pitcher into a glass. And as more water came out of the pitcher, the level in the glass rose. We got more water in the glass. More inputs gives us more outputs. And that works in a huge number of domains, but it doesn't work everywhere. In particular, it doesn't work automatically when we have a structured system. What's a structured system? Well, here's a mosquito. Supposing we're in the 1950s and we're going to write one of those Class B movies with some scary thing, and we decide that wouldn't it be scary if we took mosquitoes and we blew them up by 100 times and we had a mosquito the size of a dog and herds of mosquitoes were going to descend on the town? Wouldn't that be scary? Well, it turns out that outside of a movie, 100 times bigger mosquito is not 100 times more scary. It's probably not going to be able to fly, probably can't even stand up, might not even be able to breathe. So it turns out that in the real world, there are constraints on what you can do to take the structured system that is a mosquito and try to scale it up. When we turn to software economics, and we use the metaphor that writing software is production, like other production activities, like building widgets or cars, it turns out that brings with it the more frame, and what's suggested there is that if we put more money in, we'll get more software out. When we talk about economics, we spend a lot of time thinking about the shape of curves. Maybe if we spend $1 to get a line of code, we get some linear shape such that if we spend $10, we get 10 lines of code. It's completely linear. It could be that it's increasing returns of scale, where above a certain level, we get more than one line of code for every additional dollar. Perhaps more realistically, it might be diminishing returns of scale, where past a certain point, we get less than one line of code for each additional dollar, but we're still getting more code, so it's still worth it to us, particularly if we're in a hurry. We say, well, let's spend some more money to get more lines of code. That's the way the Moore frame works. But in reality, I'll suggest that at high cost, we can get absolutely less software. We get decreasing returns to scale. If we throw too many people and too much money at software, because we're building problem representations, and it's not just laying bricks, we may get absolutely less software, to the point where we may get no software. So that's the fundamental challenge of the Moore frame when it's applied to software. So that's the BPM frames. Let's talk about what's happened in the last 20 years. The BPM frames are old. They've been around for a long time. And in the last 20 years, we have this new notion of Agile. We have things like Scrum and SAFe. So how do those new ways of thinking interact with the old ways of thinking? We'll bring in one more idea from cognitive science, a conceptual blend. We have a conceptual blend. We start with some generic space, and then we have two different spaces that share something with the generic space, but are somehow different from one another. And then elements from each one are brought together in a blend. And the notion of blend suggests a mixture, but it doesn't suggest the logic of that mixture. So that's what we want to take a look at. Well, what's an example of a blend? How about a Christmas tree? We've got winter, and in winter, within the Christian tradition, we've got the celebration of the birth of Jesus. Meanwhile, in Northern Europe, we have these evergreen trees in the middle of a cold, dark time of year when everything else has lost its leaf. Those two very separate things are brought together in the idea of a Christmas tree. In significant parts of the world, that's a way we bring those two things together in one blend. How does this work in software? The scaled agile framework, SAFe, is, I suggest, a blend. We have the software domain, and then we have the BPM frames. They bring things like a plan, an architecture, and the Moore frame to bear. We also have an agile software frame, and from there we have things that are directly shared, using the solid line to indicate that. We have a notion of a release in both in both of these domains. The agile domain brings with it the notion of iterative, of working things that we can demonstrate frequently, of smallness, and then some of these things, not all of them, are brought together from each side to make the conceptual blend that we think of as SAFe. We get a framework from the architecture side. Got a release train, which definitely comes from the agile side, and with some contribution from the notion of a release in old style development. And most importantly, the Moore frame comes in and is renamed scaled to give us the idea that we can take these agile concepts and scale them up indefinitely to meet our large organization needs. And that gives us some sense of comfort. There's probably a reason why it's called SAFe. It's the idea that we can do these new things in some sense in the old way. And so it works as a blend. The question is, how does it work in the actual world? Let's take an example of how the BPM frames play together in support of a large organization. Here's the context. A large organization, pretty much by its nature, moves slowly. We have a related set of needs that the organization perceives has been unmet for a long period of time, years, maybe a decade or more. We get organizational will rallied, and that takes some time to decide to address these needs. The organization perceives it's late to the market. It's behind its competitors because it moves slowly. It's not addressed this area for a long time, and so feels like it's behind. All right, that's our context. So we take the needs, we lump them together as one bundle to be met by one large system. So we've got the system is going to be a big building, and large is the key word here because we're bundling everything together. It'll be built, bringing the asset frame here, as a single large capital investment. So it's a big building under the asset frame, and once again, we're going to spend serious dollars here. We start a project to build the system. The project is pretty much by definition late at the start because we wanted it yesterday. And under the project frame, we can spend more funds to trade off time against money. So we've got more money, we have less time. So we'll spend more money hoping to shrink the schedule. The shortened schedule, however, requires that we have more components built simultaneously. To meet the schedule, development might begin before the architecture is really complete. It might exist at some level, but the details have yet to be worked out. To manage our costs, the project tends to be staffed with a few high-cost resources, think architects, and many low-cost contractor resources. Some of them may well be offshore. Nevertheless, we get a high burn rate, and that generates repeated efforts to optimize all aspects of the project, and that leads to repeated changes in plan and staffing, which generates more complexity because we have to manage all that change. The concurrent component development tends to lead to unstable component interfaces. We've got multiple components interacting. We haven't figured everything out about this one, but this one over here needs it. We end up with some delays while we're waiting for changes in components, and the mismatches between components tend to persist over time. We got this high burn rate generates pressure to deliver as quickly as possible, which tends to lead to marginally tested components. They work in some set of happy paths, but not all the error recovery is worked out, which tends to lead to lower quality. And so this high burn rate and the low delivery rate tends to lead to, at best, a mediocre system with many defects, and at worst, it could lead to cancellation of the project. So that's how the BPM frames interact with each other for a large organization when we try to build a big system. And the ability of things like Scrum and SAFe to mitigate that is marginal because the BPM frames still are driving some of our fundamental thinking, and we can only mitigate that to some degree. If we accept the idea that this pretty simple model of how we currently think about software development using the building project and more frames has some value, then the question is where do we start? The BPM frames are simple. They're in all of our minds. It's not that they're not useful. They're useful in many contexts. The suggestion is just that they're not very useful when we're writing software. So our challenge is, how do we let go of this? Well, the challenge is across the whole organization, these frames exist in everybody's mind. So many people have to put the frames down and use something different. Not only are they in our brains, but they're also embedded in our processes. They're embedded in our compensation systems and how we incentivize ourselves. So any change around this is going to be many years in the making, and we'll have to proceed in many gradual steps. So what could a starting point be for an executive? I'll give one example, but I want to suggest that this is an invitation for a conversation. There's a lot of possible ways to gradually move this along once we become become conscious of the way these frames are shaping our thinking. Let's take maybe the most important way we could intervene. The next time you as an executive are invited to help sponsor a big system to meet a whole bunch of unmet needs all at once in one well-crafted, well-presented, well-marketed big system, the suggestion is that you do whatever it takes to resist that temptation. That instead, we come back to our clients and say, let's look at, say, this medium-sized problem. What problem could we put in there? And a couple of small systems to support that. And let's get that sort of stuff, this sort of core set of needs met without pretending like we're going to do it all at once. And then once that's in, stable and solid, then maybe we'll do another medium system with a couple of other supporting systems, trailing along behind. And what we end up with is something that spends much less money and takes much longer, but has the prospect of allowing us to succeed in developing stable bits of smaller systems, medium-sized systems at best, so that what we end up with is software that's maintainable over time, that we can gradually evolve to meet our clients' needs over the long haul. So that's maybe the core thing to try to take away from this. This is the beginning of a conversation. If you're interested, reach out. Thank you for listening.